So now let's take a look at the graph of y equals x squared. Compare it to both of these, where we have 1/3 x squared and 2x squared. So if you want to give those a shot, go ahead and pause the video and try those out. If not, I'm going to jump right on into it and let's talk about what do those look like when I graph them. So I'm going to graph for part A, I'm going to graph both of them, x squared and 1/3 x squared. Notice the difference. Now, what used to be my vertex at 0, 0 did not move, still my vertex is 0, 0. But on the original, when I plugged in a 1, I got 1. When I plugged in a -1, I got a positive 1 as well. It's almost like a slope. If you look at the number in front, it's 1 over 1. To be careful thinking of slope that way. However, it still can be done, because remember, we're talking the slope of a secant, not a slope of a linear equation. And so it's going to go through it twice. It still works, gives us an idea of what the graph shape is. Likewise, when we look at the other one, now if I look here, for 1/3 x squared, instead of going up 1 over 1, which is the number in front of x squared, you have to think of it a little differently. It's not up 1 over 3, it's up 1/3 over 1, because it's now 1/3 as tall. So this right here, this point is located at 1 comma 1/3 instead. And likewise, we have the same point on the other side, which is -1 comma 1/3. So yeah, it's like a slope. It is 1/3 as tall. So if you want to use the slope method for a quick sketch, make sure you do the number in front over 1. It's trickier to do, but it can be done. It is, again, a trick in how to graph those. Looking at part B, we're looking at 2x squared. Let's take a look at the difference here. Notice that for this one, we still have the same points of 0, 0, 1, -1, or 1, 1, and then -1, 1. But when it comes to my other graph, when I plug in the 2, it is going to be up 2 over 1. And then same thing on this side here. It is twice as tall. Almost like a slope. And that one is easier to tell, because even if I did slopes for this, I would do 2 over 1. The difference is when you have fractions in front of a quadratic, we have to take that fraction as the number, how high you go up. It's different. It's not 1 over 3. It's 1 up 1/3 and then over 1 still. It's a little different to think about, but it can be done to help you do a quick sketch. Because as we know, 1/3 is going to change your graph. 2 is going to change your graph. So when the absolute value of a, the number in front of the x squared, is small, the parabola is going to be wider. It's going to vertically shrink, so it's going to look wider. Then when the absolute value of a is large, meaning it's going to vertically stretch. So notice the difference between those two. This one is a vertical shrink. That is, it looks wider. For this one here is a vertical stretch. That means it's going to look narrow or narrower. It's hard for me to say. So it is, if it stretches vertically, that means it's skinnier. The parabola is narrower. If it's a vertical shrink, it's going to look like it's wider. All right. The standard form of a quadratic function, however, is a parentheses x minus h plus k. The vertex, and we can often even call this one the vertex form. And we call it that because the vertex literally is staring right at you. It is given by the values of h and k. Just like we done with transformations though, remember, you look inside the parentheses, x minus h. It's trying to remind you that, hey, x and whatever is with it is going to be the opposite. and then k, what you see is what you get. So a lot of times you're given equations in standard quadratic form, not the vertex form for a quadratic equation. Be careful with those. The ax squared plus bx plus c, you're given it in that form, and you want to put it into the vertex form of an equation, of a quadratic equation, which means that, hey, I can look at this and I can get the vertex. I know what if this is going to be upside down or it's going to be right side up. I know if it's going to stretch or shrink because I just have to look in front of it. There's a lot that can be told by the vertex form of a quadratic function. So we want to put it into that form sometimes. There are two options for this. First option is use the negative b over 2a method. So let's go ahead and try that. If you want to try this on your own, by all means, pause the video and you can go ahead and try that out. First of all, when I'm looking at 2x squared, remember this is ax squared plus bx, and then plus c. I know that x is going to be equal to negative b over 2a. I can get my vertex, my h and k. For that matter, because the vertex is located at h and k, we might even want to say this is h instead of x, because h is the x value of the vertex. So negative b over 2a, that is negative 8 over 2 times 2. And this one's going to be a lot nicer than the last one. So h is located at negative 8 over 4, which is negative 2. So that's the x value of the vertex, that's h. To find k, I simply plug that in. Once I know that value, again, the y value of the vertex, I plug that in, I get the y, which in this case is the k, is equal to 2 times negative 2 squared plus 8 times negative 2 plus 7. So again, I'm finding the y value at negative 2, which happens to be where my vertex is located. So for this one, negative 2 squared is 4 times 2 is 8. 8 times negative 2 is negative 16. And then plus 7, all good numbers. This is equal to negative 1. So I know that h comma k, my vertex, is located at negative 2 comma negative 1. So then all I need is to know the a value. But there's no trick to that because I already knew the a value because that's how I even started this thing. So this, in standard form, would look like y equals a, which is 2, parentheses, x minus h, which is the x value of the vertex, which is negative 2, so minus negative 2, square that, and then plus the k value, which is plus a negative 1, or just minus 1. So that is my parabola. That has now been cleaned up a little bit, looks a little different, and you might be asking, okay, where's the 2x squared and the 8x and the plus 7? All of that is packed inside of that parenthesis squared. And then you distribute the 2 and subtract 1, and you can try that out. FOIL it out, multiply by 2 and subtract 1. I guarantee you're going to get back to the original equation. But the green version here is a lot cleaner. Alright, so that is again using the negative b over 2a to find h, or for that matter, we can even say this is x for the vertex, so h, and then find the y value for the vertex, which is k. Then I know that my vertex, I know my a value, I can just plug it into the function. Alright, the other method is a little more complex, but it can also be done. That is called completing the square. So just to get this out of our way right now, let me see if I can be lazy. I want to move just this guy. I don't know if it's going to let me. No, it's not going to let me. So I'm just going to use this space right below. So if I want to do this other method, this is a little more complex, but however, it is a way that works. This is called completing the square. Now, at some point, we're going to have to use this method. But for now, you have the option to do the h comma k, the negative b over 2a version. But if you're asked to and you have to complete the square, first thing you start off with is your equation, y equals, and then 2, and then you have to separate that. You have to bring the 2 out by factoring the 2 from this equation. It's going to leave me with x squared plus, instead of 8x, I factored a 2 out, and then plus something. And then the 7 is not involved with x. But then if I add a number here, I also need to subtract that same number if I'm working on the same side of the equation to keep things balanced. So if I add 5, I had to subtract 5. But there's a catch to that as well. Whatever number I add is being multiplied by 2, so I'm going to subtract 2 times that same value. So completing the square is a little trickier, so we want to be careful with it and really only use this method if you're comfortable with it. Now, when I complete the square, the rule is this. First of all, I can bring down the 2. And then I'm going to have a parentheses. And then now x squared, if I'm trying to make this parentheses squared to make it a perfect square, that means, well, what times itself gives you x squared? That's x. Then I need to know what times itself gives me not only a number here, but when I add 2 of the same, I get the number in the middle. So an easy way to do that is that you take this right here, and you're going to take half of that number. So you're going to divide this number by 2. So 4x divided by 2, again ignoring the x, is plus 2, because the x is already packed into that parentheses squared. Then, to find out the number that gets added, I multiply, well, 2 times itself. So that is 2 squared, which is 4. And the 4 goes there as well. And then don't forget, I still have a 7 there. So this is going to end up, when I clean this up a little bit, it's going to be plus 7, and then minus 2 times 4, minus 8. Again, I take half of my middle term and square that for the number that gets added. Now, there's only one last thing to do, and that's to clean things up a little bit. So x plus 2, quantity squared, plus 7 minus 8 is minus 1. And wouldn't you know, it is the same thing we got before. So completing the square is a little more efficient, but it's a lot more complicated. You have the option, by all means, use it if you're comfortable with it. Again, half of the middle term and square to find out what adds. But then that parentheses squared is just going to take x and the plus 2, half of that middle, the b value basically. Alright? So completing the square is a little more advanced, but it is an option. On this next one here, we're asked to sketch a graph. In sketching a graph, we don't have to do too much if we know what the parent function looks like and we know a couple of the transformations that have happened. So let's sketch this based on a few of those transformations. First of all, this looks like a squared function, right? X squared, so it's moved, plus 2, minus 3. What's going to happen to my graph? Well, plus 2 minus 3, this is going to go to the left 2 spots. It's going to go down 3 spots. And doesn't look like anything else is happening right now. So left 2, down 3. So there's the middle of my parabola. We also know the middle of my parabola to be my vertex. But also we just learned that this is already in that standard form for quadratic, right? This is in that vertex form, a and then x minus h plus k, where h comma k is your vertex. So opposite of what you see inside is minus 2, exactly what you see outside is -3. So -2 comma -3 is my vertex. The axis of symmetry, it is a vertical line that runs through the vertex. So here's my vertex. I have a vertical line running right through the vertex that is going to provide my mirror to this graph. Be careful though, this is a vertical line. Goes to the vertex, more specifically because it's vertical, it's going to use the x value of the vertex. So it's an x equals line. And x is equal to, in this case, -2. Now, that's my vertex, my axis of symmetry. I won't have anything else right now, right? So bonus, without graphing, what's the y-intercept? How do I find the y-intercept? Remember, at the y-intercept, x is equal to 0. So I can plug in the 0. And this is going to give me a pretty accurate sketch. And I have not, used a graphing utility, a table of values, or anything. I'm just using some of the things I know about parabolas to be able to sketch this. Now, y equals 4 minus 3. That means that my y-intercept is equal to 1. So I know it crosses the y-axis at 1. You can also find out where it crosses the x-axis, but that might be a little more complicated. So I know another point on my graph is 0 for the x, but 1 for the y. So now I got half of my graph, but remember that mirror, the axis of symmetry, right? So if from this line, from here to here is 2, I have an equal point 2 units away on the other side. That's what the axis of symmetry does. Splits my graph and it creates a mirror. So I can now connect those two here and get again, a sketch. Not a perfect representation, but a pretty good one of what my graph should look like. Alright, so this time I want you guys to give this a shot. Just notice this is a little bit different. This is not already in vertex form, so you might want to do that first before you can start. So at this time I want you guys to pause and try this out if you would like to. If not, let's take a look. So we're asked to sketch 3x squared minus 6x plus 4. First things first. I know that I can find my vertex where x, which is the h value of the, so h, which is the x value of the vertex, is located at -b over 2a. So it's located at, and again, if you don't remember, this is ax squared plus bx plus c. So now I can say, well, -b, that's negative of -6. So that is going to be +6 over 2 times, and the number in front is a 3. So that means that the h value is 1. That's nice. To find the y value, or the k value of my vertex, I simply plug in the 1 that I just found into my original equation. So that's going to be 3. Let me change colors on that. Matter of fact, let's work with red. So 3 and then squared minus 6 and then plus 4. The number I just found, the 1, goes in to find the y value, or the k value of my vertex. The k value, which is the y value of my vertex. So now I have this equals to 1 squared times 3 minus 6 plus 4. So 7 minus 6. Ah, well, that's nice. So now I found my vertex. I got x and y values. I got the h and k for my vertex, which is 1, 1. The axis of symmetry goes through the vertex. Axis of symmetry goes through the vertex, and that's x is equal to, well, the x value, 1. X is equal to h, and h is equal to 1, has to go through the vertex, so the x value of the vertex is also the axis of symmetry. Remember, this is a vertical line, so it has to literally read x equals. And believe it or not, that's enough for us to graph our, at least get started on the graph of our parabola. There's a couple other things we can do here that's going to help us sketch this graph. So now I know my vertex is at positive 1, positive 1. I know my axis of symmetry is going to go right through that point. It's going to be a vertical line. Then I know a couple other things here. First of all, I know the c value. C is equal to 4. That is my y-intercept. So on this graph, 2, 3, 4, I know it also crosses here. But remember, the axis of symmetry helps you locate another point. This is 1 away from the mirror, so on the other side of it I also have another equal point. And then just connect the dots. This is going to be pretty sharp. And it is pretty sharp because what's the number in front of x squared? It's a 3. So it's almost like it has a slope of up 3 and then over 1. And it kind of is. It's 3x squared, so it's going to be 3 times as tall. That rule, though, only works on the very first point beyond the axis of symmetry. After that, the numbers get bigger much quicker. So you're asked to sketch a graph. You need the vertex. Axis of symmetry helps, and then maybe one more point. And if you know where the axis of symmetry is, you can mirror the point on the other side.